Let's talk about Box2D. And originally, I was going to teach Game Center and iAds in session 4, but as an emailer pointed out to me, why not just keep teaching us games and stuff like that and save that for the end? So, why not? Yeah, you're right. We'll keep going with it. And what I've done is gone and already created the project for us. But what you can do is go over here to, well, you can also use my source code, but you can also go over here to new project, and what you should have is the option to choose a template for your project. Previously we've been using Cocos2D. Now we can go with Cocos2D _ Box2D as your starting project, and it's gonna, well, you'll see it in a moment, but it's got a world already set up inside of it. There is one issue here though. If I were to go, like I did just a moment ago, and create a new template project, I was running into about 4 or 5 errors. Okay, actual errors, not warnings. This is the warning sign. But actual errors, and I don't know why that is. I keep reinstalling my template from the Cocos2D folder here, which you guys have all downloaded previously from the Cocos2D website, but and this has got all the most recent code, but yeah, so I keep running into an error, and I will explain to you guys how to fix that in case you're running into the same thing, or if it's just time to update your versions of this stuff. At this time, here in December of 2011, the files to change or to overwrite in your libs folder. Okay, so here's your project. Dive into this. Go over here to libs. They're going to be these folders right here, but the tricky thing is making sure that when you copy or overwrite them, you take this subfolder called Box2D instead of the parent folder here. Okay, so just kind of go down, look at those, and those are going to be the ones that you overwrite. And of course, I've already done that, and now when I go and I open up my project, I can test it in the iPhone simulator. If I have this set to 4.3, I'm pretty sure, if I remember right, it builds with no issues. Okay. And we'll let that build up all the way. And what you should see is the very beginnings of a little Box2D world here. Okay, so we're just dropping boxes onto the screen, and you can see you can just kind of click click crazily there and get a bunch of boxes. Okay, that's not that exciting. One thing though, to keep going with what my last thought was, if you set this to deployment target of 5, or if it's just the latest version, whatever that is, you could be running into 2 warnings that just say this unique identifier is becoming deprecated, or is deprecated, and that just means that they're doing away with that little bit of code. Okay, and you don't have to worry about that. All right, it's just a warning. It's not gonna reject your app in the review process or anything like that, and this unique identifier is not something we're even going to be dealing with. So it's just a little bit of code in the Cocos2D framework that is on its way out. All right. Okay, we are going to kind of deconstruct the template. All right, so we'll go through what's currently in the Hello World layer here, which is doing all this stuff for us right now, and we'll kind of strip it down and build it back up again, and hopefully I can explain to you guys all the cool stuff about the world of Box2D. Okay, so let's go through and just kind of give you guys an overview of the template, and then we'll start really pulling it apart and recreating it in some sense. The first thing we've got here is this variable type for BT world, and this is just, they're just calling it world here. And we will kind of use this variable to pass into other objects that we create and are going to put into our world here. So basically everybody's just kind of entering into the same world, and if we were to publish this guy out in the simulator, right now, our world is just basically the what we're seeing of the screen, okay? And that gets defined, obviously, in the implementation file here. But if you could see it, you would see a little line right down here, then a ground plane here, a line up there, and a line over there. So if we were to tilt the device too, the box would go all the way to the edge of this, but it wouldn't go any further. And actually, it looks like if I click right there in the middle, it gets pushed off to the right, back inside of the little world. Okay, this debug variable right here, that gets used. Let's go over here to the implementation file right down here. In this optional code, we can actually comment this out, and it won't do any harm for us. But when we do that, we're not going to see the the vector shape around the sprite. And of course, in your final product, you don't want to see that. You don't want to be showing people the little lines around these boxes. Of course, it was kind of hard to see them in the example before, but if you looked closely, you could see this little box shape around those guys. It becomes a bit more obvious when we have shapes that are kind of not squares. And what we'll do is we'll switch this kind of on and off quite often. And in all my projects previously, I just have this same code tucked into one method. So I either call the method or I don't, just depending on what I'm doing and what I want to be able to see. So otherwise, there's actually not that much more to our header file here, other than a method for creating or adding a new sprite with coordinates. And those coordinates are just going to be where the sprite initially shows up at. And you can see in the example, that's obviously right where you tap the screen. Okay, so that's really all that that method ends up doing, and just puts a box into the world, and from there the world takes over. And that's kind of the beauty of these physics simulated worlds, is they kind of take over as soon as you put something in there. All right, so or if you were to apply force to something, whatever it is, then you're just letting the world do its thing, just like everything else in the real world out there. So we are going to eventually actually wipe out this entire function basically and just replace it with one of our own, because I don't want to show you guys an example of just A, B, C, and I guess eventually we should have a D. There's a D blocks. Even though it is kind of fun to just kind of test this on your phone and throw them all down there and stuff like that, we'll do something a little bit more real with it. And but starting back up here at the top, let's kind of quickly keep going through and explaining a little bit more about the template. This we've seen before, just returns our scene. We've talked about that in all of our examples so far. Let's cut on down here to our init statement. Touch is enabled, accelerometer is enabled. What the accelerometer does is here's that statement down here. If you kind of cut past all this, becomes a little bit more obvious. It is changing gravity, all right, based on the acceleration of either the y or the x-axis. All right, so it's multiplying the accelerometer values and then setting back, or just changing gravity right here. So gravity's already been set up. What it's doing is it's just saying world set gravity. Here's that new gravity that we've figured out for you. Okay, so obviously the higher this value, the more it's going to tilt in that particular direction. And this is something that kind of threw me off at first. The dash and then the arrow right there. You can kind of think of this just like a dot. All right, so if you're coming from, like, let's say an ActionScript background. It did actually help me to see that, because there is a version of Box2D for ActionScript 3 as well, and their version of this is all replaced by dots like that. So I don't know. For me, it just was like, oh, okay, it's nothing more than just a period in there, and you're just calling a method, called set gravity. Okay, but for some reason they have that little cool looking thing. So anyway, let's cut back over here to the top, And you can see also one of the first things they do is they set up an initial gravity of -10. And this is -10 on the y-axis and 0 on the x-axis. So you can see that in a perfectly lined up world here, like the simulator is, the box just goes straight down. It doesn't float anywhere off to the left or right or on the x-axis, because that's obviously 0. And then -10 is just the speed it puts it at. So if you were to change this at, or just down to -1, and build it again, hey, look how slow you're going there. Or if you just had this at, let's just make it go to 10, well, you can imagine what's going to happen. Hey, it goes straight up like that. All right. So now think about it like this. What if it was just 0? Okay. Then you're looking at sort of a situation where nothing's going on, but you've still got things like this that are occurring. You know, your physics are happening. Obviously, these are pushing these guys off to the side. And you could still apply some sort of left or right acceleration to all of these boxes based on the, that previous method I just showed you guys. So just know that that's possible. We'll keep it at 10 though. Do sleep. And this says this will speed up physics simulations. I'm going to set this to false actually, because I'm kind of getting to the point where I'm not too worried about the speed of this world, because I've done some I think some kind of intense things to it, and I haven't noticed a significant slowdown with it, with sleep on or off. And I'm sure in some situations you do want your objects to go to sleep, but and by sleep they mean if the object were to, I need to just have a copy of this running at all times. If the box were to fall down to the bottom, or the object were to fall down to the bottom and just kind of stay there for a while, it's going to go to sleep. Okay, so it's not going to get affected by certain things that you do. Okay, but I'm going to, like I said, I'm going to turn that off so that at any time these objects that are just on there can be, fully affected by the physics in the world. And here we go. So we've actually done some things even prior to creating the world here. All right, so now we're saying world. All right, remember that's our B2 world here, equals new B2 world with a gravity of this, and then this option for whether or not they're going to sleep. And then set continuous physics for true. To be honest, I've never actually tried setting this to be false. It just doesn't sound like something you'd even want to do. But doing a little bit of a quick Googling there, it seems like you want to have that set to true, and especially if you're using fast-moving objects. And I don't know what you'd really define as a fast-moving object. I guess some sort of bullet or something like that. But, if they have it on for the template, I'd probably say it's generally going to be something that you want to keep active here. Certainly if there's a lot of objects colliding with each other. Okay, we talked about putting the debug draw functions into their own function. Let's go ahead and do that now so we can have this ready to go. So what we'll do is we'll say self enable debug. How about mode? All right, then come down here. Paste all that stuff right back in there. And now, oh, here we go. Let's copy that and put it into the header file. Oops. Just so we don't get a warning. So if we want to see kind of the, pristine version of this without some, wireframe boxes around every object, we want to comment that out. Otherwise, we want to leave that on. All right, now defining the ground body. And actually, we're kind of just defining our first shape here, okay, inside of the world. They're just calling it ground body, but they're making a box inside of our world. And this kind of follows the same pattern of any shape or object we're going to be putting inside the world here. We're going to first have a body definition, okay, and one of the things they do here is they just write BT body def, they name it, and they just say the position is going to be 0, 0, bottom left corner there, okay. Then we make a B2 body, all right, they're calling it ground body, and world, create body, ground body definition. Again, if it helps your minds to think, to write it like that, go for it. I mean, you can't write it like that, but just consider that little thing saying, all right, with your world, do your little method called create body, and for some reason you have to throw that ampersand sign inside of the before the ground body definition right there. All right, now we've got ourselves a body. What we need to do is define the shape of it, okay? And keep in mind too that our body doesn't necessarily have to have any sort of artistic representation of it, okay? We're not creating a sprite to go along with this body. We're just creating the shape of it, okay? Because it's our like little invisible world that's surrounding us. So, and that's exactly what these next few lines of code go through here. All right, B2 polygon shape. You'll see in other examples what we do is, let's see if I can find one right now, actually. Well, we've got some other options by default for like, or just some easy setup ones like B2 circle shape. All right, so if we're gonna want to go with the circle, we'd set like circle shape. All right, and we'd further define it down there. And another one would be B2, I think, polygon. Yeah, polygon shape. And for most of my projects, that's the one I've been going with because I haven't needed exactly a circle. I haven't needed exactly a box. What I've needed is a polygon shape. Okay, so it's kind of a, anywhere from like 3 to 8 points around a shape that are defining it. And of course, we'll get into that a little bit later. But for right now, for our world, a polygon shape is just fine. So then all they're saying here is that the ground box is going to set as an edge this B2 vec2 point, and this is similar to CCP, all right, CG point make, but in this case it's going to be this B2 vec2, all right. But again, it kind of basically just boils down to your X and Y point for the beginning edge of this, and then they're putting inside of here your screen size dot width divided by your PTM ratio for the next edge that they're writing inside of here. So this is just the bottom plane. All right, so left side 0, 0, right side is going to be the screen width, basically. And then this division is because, and let's go ahead and look at what PTM ratio is. That is 32. Okay, why are we dividing by 32? And, well, here's the explanation for it here. It's your pixels to meters ratio. All right, and Box2D doesn't really use pixels, it uses meters. All right, and I'm trying to think of one example I heard for why that was. Well, let's say like 1 pixel represented 1 meter. All right, well then, if you were making a box, let's say the size of the screen height on your phone, you're kind of like making something the size of the Empire State Building. All right, and just for practical purposes, that's not really, they're trying to keep to a realistic world here. So, this helps in that. But anyway, so 32 pixels is essentially 1 meter. Is that correct here? Pixels to meter ratio. Well, anyway, you'll see that quite a bit throughout here, and we'll obviously talk more about the PTM ratio at times. So anyway, yeah, that's creating that edge, and then they're going and saying ground body. You're going to create a fixture. All right, so we're using this shape right here, And yeah, actually the only question here in my mind is what that 0 is there afterwards, and I'm kind of suspecting it's let me just try changing it to 5. We'll see what happens. And we are enabling debug mode, so we should, if I've made a change to this, we should be able to see it represented on the in the game here. Well, let's see. I'll have to look that up for you guys. But you can try playing around with just changing some of these. So let's say you put 1 and 1 here. All right. Oh, look at that. And obviously, this didn't just bump us up 1 pixel, it bumped us up 1 meter. Okay. So wouldn't that be 32 pixels, right, with our PTM ratio? So let's try it again. Here, I'm going to try to use one of my little tools here. Looks about right. Look, see that little number that's going, that little guy right there. So yeah, that's about 64 pixels. So hopefully that makes a little bit more sense for you guys. All right, let's knock that back to 0, and I'm gonna have to pause the video because now I want to know what that exactly that value could be. Okay, I got my answer. This is the density of it, but since this is not a dynamic shape, meaning it's a static shape, so it's just going to stay there, fixed in place, it just goes to just gets set to 0 there for the density. Okay. Density will matter a lot more when we're dealing with a dynamic shape where, you know, let's say, what's the density difference between a bird's egg and, you know, a metal ball the same size? You know, it's obviously one weighs a lot more because of the material it's made of. So that's, I guess, how dense something is. And you'll definitely see some, you know, how objects react differently based on their density definition. Now, of course, we're not defining that inside of here, but we will see that in just a moment. Anyway, you can just go through here and read bottom, top, left, right. It all makes sense, you know, if you just kind of go through and think, oh yeah, all right, screen size, dot width, PTM ratio. Okay. Now, set up the sprite. Okay, like I was saying before, we are going to eventually not do this, okay, or kind of get rid of what's currently going on in this template, but they are yeah, they're just calling this method right here from right here, and they're doing it with this CC Sprite batch node, which is not something we're gonna do in this part of the tutorial, create a batch file. But if you were to go and look at the resources here, all right, they're using blocks.png. It just comes down to picking out an image from inside of this image. Okay, we're going to use, you know, an entire image for the shapes that we end up creating. But let's just kind of continue on here. So that what they're doing is they're saying add new sprite with coordinates, and let's go down and find out what they're talking about. All right, so the coordinates eventually get passed into this as a CG point, and they're just calling that that point P from here on. Okay, so P.x, P.y. So if you were to look in the output window when you create one of these shapes initially, or if you do it based on a mouse touch, you're going to see adding sprite at, you know, wherever it's at. All right, now again, let's just kind of ignore the stuff to do with the actual sprite batch. Let's go down here, and again, that's all they're doing here is just picking out a random slice of that image. Okay, there's our sprite. All right, they're just calling it sprite. That's a great name for that. And they're saying the sprite position is going to be P.x, P.y. Okay, so again, if it was a finger touch, that's what it's going to create a sprite where your finger was at. All right, now here's the good stuff, the Box2D related things. B2 body def. All right, now we saw that same exact thing right up here. Okay, B2 body def. All right, that time they called it ground body.def or ground body def, and this time they're just calling it body def. All right. Body def dot type. Okay, that's not something we saw before. Is going to be B2 dynamic body. Another option here could be static body. Okay. That would be one that when it gets placed inside the world just stays there. Okay. And I'm pretty sure, actually I'm not pretty sure, I'm like 50% sure, if we were to test this out and only change this to a static body, it doesn't matter if the gravity's still on or not, the body should just stay there. Yep, sure enough, there it is. Okay, and look at that, they don't even get out of each other's way like they were before when we had the gravity off. They just are just straight up on top of each other like that. Okay, so good to know what those do. So we have that option there. Let me just comment that out. All right, so it's going to be a dynamic body, and so the physics are going to get applied to it, those collision physics, things like that. And then, again, it's just like we were with our ground object. It's setting the position right away. And then, this is a little new one. It's saying our user data is going to be that sprite. All right. Which will be obviously something we look at later on when we are creating our own sprites, like a character in a game or whatever, that we want to have our user data equal to a particular image. All right. And they get locked together. We'll see that later on. You know, so like if the body moves or rotates, so does the image. And you can also prevent in fact, you know, if I were to just scroll down here a little bit further, I could kind of demonstrate a bit better. In the world where we have a method that's constantly running with the frame rate that is adjusting those sprites based on where the boxes are at. Okay, and that's really all this comes down to. Basically, it's just saying for the bodies in the world. Okay, let's call them actors at this point. Our actors, we want their position to be the same position as the body, and same for the rotation. You know, but if you were to uncomment out just the rotation part, all right, watch what would happen. Oh, look at that. See, notice how the box changes, but the sprite itself doesn't rotate. Okay. And I use that actually in the pinball games I've made because I had a gradient on the pinball, that the artwork I'd made that was kind of always showing the upper left portion of the pinball had a, you know, that was the bright part of it, you know, the light reflection, and it just didn't look right to have the ball kind of rotating like that, because that's not how it would look in the real world. No matter where a totally reflective ball was going, the light source is always going to be in that top left. So I just disabled the rotation of or the artwork rotation of the ball. But of course, in the physics world, it was always still rotating. It just wasn't showing that to us, the viewer of it. So anyway, let's back up a little bit. All right, so now you know that they're tied together like that. Next up, let's go through here. Again, we're saying that we have a body. All right, we're calling it B2 body, and inside of our world, we're creating that body with this body definition. All right. And, you know, if you guys were to do some Googling of the official Box2D API, you can find out lots of other different options you can specify for your body definition, things like that. But, you know, we're just going to keep going through what's the basics for now. All right, so going on down through here, define another box shape for, oh, right, they're saying another because, yeah. Anyway, B2 polygon shape. All right, now that is a little bit different than what we saw up here. No, they had polygon shape. I thought they had a rectangle shape. Wait. Did I imagine that? Guess I did. I don't know. Anyway. So, all right, well, that's even easier. Same thing. Polygon shape. All right, dynamic box. Set as box. They do make it a little bit easier in this version of it, because instead of going through and creating edges, they're using just a straight up box. Okay, so saying these are the midpoints for our 1 millimeter box. Okay, so that makes sense. If it's a midpoint, it's going to be 0.5. And then the B2 fixture definition. All right, now that's a little bit of a departure from what we had up here, because what they did up here was just say our ground body is just we're just gonna create a fixture using our ground box. Okay, so that's our B2 polygon shape, and we're just gonna give it. We're just setting the density to 0 because it's a static box. All right, now what they're doing down here is they're saying we're gonna fine tune this a little bit. Okay, we want our fixture definition to have some specific properties like a density of 1.0f. We want the friction to be 0.3f. Another thing you can do is you can set up your fixture definition restitution. This is how bouncy something is basically. Let's try putting in 1.0f there. And let's see. Does it not like that? Oh, well, it doesn't like me not using a semicolon afterwards. All right, so basically this is just a little extra layer of definition for our fixture def. All right, so what we've done is we've said fixture def.shape is now going to equal our dynamic box, or our B2 polygon shape. And then our fixture def kind of holds on to that shape, but also adds in density, friction, restitution. And then finally we put body.create fixture and then that fixture def. Whereas before, with just that simple ground plane, we kind of, in a sense, skipped over the fixture definition, just said create fixture def with just our ground box. Okay. So now let's try this. Let's try to, well, let's just publish it with that little bit of restitution added in there. See if we can notice much of a difference. Yeah, that's a big difference, isn't it? See, now that thing's really bouncing around. Hey, look at that. I could kind of think of some games based on this guy here. Yeah, that's a lot of bounciness. I didn't think it was even going to be that much. These things are just not staying still now. Eventually they should, right? Yeah, it's kind of amazing actually, because there's really, other than gravity pushing down, there's really nothing else going on affecting these guys, because the accelerometer is not doing anything. Boy, take it easy, guys. Okay. All right, well, so that takes care of, just this. We are going to, we're going to go through all that one more time, at least one more time, with some shapes of our own. But they do kind of follow the same pattern, where we have a body definition, then we create the B2 body, then we have the shape, and then optionally we can add that shape to the fixture definition, and then we kind of end by creating the fixture itself, or applying that fixture to the body, I should say. All right. Well, let's go back up and look at our tick-tock. This got called over here in our init statement. Okay, so there it is, init, self, schedule, selector, and as you can read down here, it is recommended that a fixed time step is used with Box2D for stability of the simulation. However, we're using a variable time step here. And I believe if you wanted to use a fixed time step, all you've then got to do is just say interval 1.0f divided by 30. Oh, sorry, 60 point. 0f. And I think that would do it. I'm not positive. That's not actually something I've done that much with. You know, it doesn't look that much different to me in here. Maybe on the phone it's significantly different. But let's just go with what they've, you know, at least for our example, we'll just set it back to the default, and we'll go with their variable time step. Okay, velocity iterations and position iterations. Ew, I don't know what to say much about this because I've not seen a difference myself with these guys. You know, I've seen examples with 10 and 5 inside of here. Generally, what I've read is that you might want more velocity iterations than position iterations, but again, they're going with 8 and 1. You know, probably for what we're going to do in this example, it's not going to make that much of a difference. Okay, and again, I did kind of explain this before. I mean, I can get into it a little bit further, but you know, we've got some real examples coming up where we use this, essentially the same for statement that says, that iterates over all the bodies in the world, and so for B, that's just, they're just shortening down body here essentially for body, and then you know, they're looking at our world, they're getting our body list, and they go through and they get the next one. Okay, again, I'm just kind of quickly explaining this, and then they write if the user data does not equal null, okay, then that means it's got user data. All right, and again, let's look up here. Remember, user data equals sprite, so if it's got a sprite attached to it, then we're going to say that that is a CC sprite. It's now going to be our actor, at least for one iteration of this for loop. And we are saying my actor.position is now going to equal the body position. Okay, so it's getting that X position for it times PTM ratio, so times 32. And so on like that for those guys. And then obviously the same thing's going on here for the rotation. All right, so again, they're doing a little math on it. CC radians to degrees. They're getting the angle of the body and then just applying that to the actor. And I'll be sure I do some example where you know, we kind of change the rotation on the fly or change the position of a box. In this little physics world, they kind of call that, they kind of consider that like warping your box from one place to the next, because you know, the beauty of a realistic physics simulation is that you're trying to keep things kind of real, you know, so I can't just warp myself to the other side of the room. We can do it in this world, but what you'll end up doing a lot of time is applying force to something. Okay, so I could apply force to the back of my body and send myself shooting into the other side of the room, and that would be more realistic than just kind of grabbing me out of nowhere and putting me into some new spot. But so we'll look at things like that, how we apply force to things, how we warp something to some other place, how we make an immediate rotation or not immediate rotation. And but yeah, I think actually I've kind of explained this template pretty well, because now we're back down here at just CC touches end, and we've seen, you know, how to get the location of a touch, and all they're doing is just adding a new sprite with coordinates based on that location, and which just brings you back up to everything we just talked about again. And we already looked at the accelerometer. Yeah, and then the dealloc statement is just deleting the world equals null, and they're just deleting the debug variable there as well. Okay, so template explained. Anybody? Do you agree?